Welcome to Dynamic Coaching Center. So in this series of videos, we'll be seeing through the past 25 years question papers of SSC JE. Okay. So to start with, we'll start with the thermodynamics part first. Okay. So this is a question which has been asked in the year 2007. According to which law, all perfect gases change in volume by 1 by 273rd of their original volume at 0 degree for every 1 degree change in temperature when the pressure remains constant. So which law actually represents this statement? Option A is Joule's law, option B is Boyle's law, option C is Gay-Lussac law, option D is Charles' law. Okay, so the thing is, according to Charles' law, it states that the volume of a given mass of gas varies directly with respect to its absolute temperature, provided pressure remains constant. So, according to Charles' law, it is said that volume by temperature is equal to constant, or you can even say that volume is directly proportional to temperature by maintaining pressure as constant. So this is what the statement is all about as far this question is considered. You can see, according to which law all the perfect gases change in volume by 1 by 273rd of their original volume. I'll come to this point. What is this 1 by 273rd? Okay, but it is clearly said that it is actually changing with respect to temperature, but the pressure remains constant. So it is clearly the answer is going to be Charles' law. Okay. So I'll give you one more expression for this. So the thing is, you have got this expression V minus V naught by V naught T is equal to 1 by 273 minus gamma P. Okay. Where this gamma P 1 by 273 is called as the volume coefficient of gas at constant pressure. So if you want, you can remember this expression also. So I can say that volume coefficient of a gas at constant pressure is actually defined as change in volume per unit volume per degree centigrade rise of temperature. So that is the exact meaning by which they are asking this question. So, but by clear and simple terms, I can say that the volume varies directly with respect to temperature by keeping pressure as constant is being related to Charles' law. Okay, so let's get into the second question. So this is a question which is again been asked in the same year 2007. Properties of substances like pressure, temperature and density in the thermodynamic coordinates are. So option A path function, option B point function, option C cyclic function and option D real functions. Okay. So whenever you deal with the properties, thermodynamic properties, so properties, thermodynamic properties like pressure, temperature, density, they are all called as state function because for a particular state, they have a particular value, pressure, temperature, and density. So here they have clearly asked about the pressure, temperature, and density in the thermodynamic coordinates. So these properties are called as point functions because they represent a particular state. Okay, so I can even represent like this. Say for example, let's have a temperature versus entropy curve where I'm saying that this is a particular process which is happening between the states 1 and 2. So for this particular state 1, it is having a unique value of temperature and unique value of entropy. And similarly for the second state also you have a unique value of temperature and unique value of entropy. So I can say that these are all the point functions. So the answer is point function. So let's move on to the next question. So this question has been asked in the same year 2007. So you can see that whenever you are familiar with the first law of thermodynamics, zeroth law of thermodynamics, second law of thermodynamics, you can attend as many as questions possible. regarding any competitive exam, and you can follow this series in our channel for further updates. So that I think so this JEE has been called for this year 2024, which you can apply and go through this series. And don't worry, as many students are asking for the coaching classes also, which will be provided free in this channel. You can just watch out. Work done in an adiabatic process between a given pair of n state depends upon option A, n states only, option B, particular adiabatic process, option C, the value of the index n, option D, the value of heat transfer. So it is said that work done in an adiabatic process. Clearly, it is said that it is an adiabatic process, and they are asking about the work done. Okay, whether it depends only on the end states or a particular process, or it depends upon the value of index or the amount of heat transfer. Okay, so the thing is, we know about the first law of thermodynamics. First law of thermodynamics. So according to the first law of thermodynamics, for any process, we can say that Q is equal to del U plus W, right? So since it is said that in this question it is adiabatic process, so adiabatic means it is perfectly insulated, which means the heat transfer is going to be zero. So this is zero. So my W, work done, will be equal to minus del U. So I can say that this depends only on the internal energy, which is a property. So I can say that it again depends only on the n states. Just like the previous question, what we have seen. See, this is the n states, right? Like for this case also, we know that work and heat are actually path functions. But for this adiabatic process, it ends up with entropy, internal energy. So I can say that again it is a property. So it depends as a point function. So it depends only on the end state. So I can say that option A is the correct answer. Now we'll move on to the next question. So this question is being asked in the same year 2007, which is true for reversible polytropic process. So polytropic process, we know that PV power n equal to constant. Four options have been given. Option A, temperature remains constant. Option B, entropy remains constant. Option C, enthalpy remains constant. Or option D, some heat transfer takes place. Okay. So in polytropic process, see, basically you have two different process. One is the reversible adiabatic process, and you also have irreversible adiabatic process. But adiabatic generally means heat transfer is zero, and then you also have something called as polytropic process. So for this process, you will have PV power gamma equal to constant, whereas for this one you have PV power n equal to constant, where this n is nothing but your index. In adiabatic process, you can say that your Q is equal to zero because of the insulated condition. But in case of polytropic process, it is a real process where both heat transfer and work transfer will definitely take place. Okay, so in that case, if you just go for the option, I can say that option D would be the correct one because some heat transfer definitely take place. So the next one is, we'll go for another question which has been asked in the same year 2007. Change in enthalpy in a closed system is equal to heat transferred if the reversible process takes place at constant. So what is that process for which change in enthalpy is equal to heat transfer? Change in enthalpy, delta H, is equal to heat transfer for which process? And we assume that most of all the processes are reversible for solving the problems and everything, and they have given four options. Option A, pressure. Option B, temperature. Option C, volume. And option D, internal energy. Okay, so we have been given with constant pressure, constant temperature, constant volume, and then they have given also internal energy. Okay, so they're asking about the process, so this is not going to take place. So one is either it could be constant pressure or constant temperature or constant volume, right? So if you just take down this process of first law of thermodynamics, Q is equal to del U plus W. And you know that del U for any process, it is mCv delta T. And this delta T can be written as T2 minus T1, right? So if it is a constant temperature process, this term will vanish. So I can say that Q and W are equal, right? But Q for this case of constant temperature is exactly equal to that of work. Okay. So if you go for constant volume process and apply the same first law of thermodynamics, I can say that since it is constant volume process, there is no change in boundary movement. So the work done is going to be zero. So Q will be equal to del U, which means Q in this case is actually equal to del U, which is nothing but MCV T2 minus T1. But what happens for enthalpy? So enthalpy basic definition is actually it is internal energy plus flow work. Okay. So if you just substitute MCVT plus instead of this PV, if you go for MRT and then this MCVT plus instead of this R gas constant, you can put Cp minus Cv into T. So you'll end up with MCVT plus MCPT minus MCVT. So these two terms will get cancelled. So we'll end up with MCPT. So if we go for change in enthalpy, it is actually equal to MCP T2 minus T1. So for constant volume process, your heat transfer will be calculated as MCV T2 minus T1, which I have already shown you. Similarly, for constant pressure process, your Q can be proved that it is equal to MCP T2 minus T1. So this is same as that of the enthalpy change. So I can say that constant pressure process is the correct answer, where the change in enthalpy and the heat transfer are one and the same. So we'll move on to the next question. So for which of the following substance the internal energy and enthalpy are the functions of temperature only? Okay. For which of the following substance the internal energy and enthalpy are functions of temperature only? Option A, any gas. Option B, saturated steam. Option C, water. Option D, perfect gas. It has been asked in the same year 2007. See, we can prove that internal energy is a function of temperature alone. Just now in the previous case, we have seen your change in internal energy answer as MCV T2 minus T1 for any process. And similarly, change in enthalpy as MCP T2 minus T1 for any process. These conditions are valid. So I can say that enthalpy is also a function of temperature. These conditions are valid only if it is a perfect gas. Should obey the perfect gas law. Okay. So that is the only condition. So I can say that perfect gas is the correct answer. So we'll move on to the next question. So characteristic equation of a gas is given by where V is specific volume, M is mass of the gas. This question has been asked in the year 2008. Option A, PV equal to RT. Option B, PV equal to MRT. Option C, PV for N equal to constant. And option D, PV for gamma equal to constant. So what is a characteristic gas equation is what the question is, right? The thing is, there is a twist here. Generally, the characteristic gas equation is given by PV equal to MRT. This V is volume and this M is mass and this is gas constant, this is temperature and this is pressure. So here they have clearly mentioned that this V given in the option is a specific volume. So what is meant by specific? What is meant by specific? So any property divided by mass will give you the specific property of that same. For example, volume by mass will be specific volume. Similarly, entropy by mass will be specific entropy. So now what I'm going to do is I have V, which is the exact thing which is given in the characteristic equation. But according to this question, I don't have any such volume. I have only specific volume given. So which means if I bring this mass over here, so it would be P is equal to PV by M equal to RT. So this V by M will become specific volume, which means I can say that option A is the correct one. So you have to be very careful while choosing the option. Now we'll move on to the next question. So this is a very famous question which has been asked in GATE, engineering services exam and everything. So you guys can actually watch out the series for all GATE and ESC videos which we have published so far, and it will be continuing process. So here this question has been asked in the same year 2008. Zeroth law of thermodynamics defines. So what is the main thing which has been defined using zeroth law of thermodynamics? So option A, internal energy, option B, enthalpy, option C, temperature, and option D, pressure. Okay. So I can say that your zeroth law of thermodynamics forms the basis of temperature measurement. So zeroth law of thermodynamics speaks everything with respect to temperature, which means it defines the temperature property. Whereas the first law of thermodynamics, I can say that it has been completely related to internal energy. Okay. So I can say that zeroth law has been completely related to temperature. So option C is the correct one. So the next question has been asked in the year 2009. So here it is said that the first law of thermodynamics furnishes the relationship between option A, heat and work, option B, heat, work and properties of the system, option C, various properties of the system, option D, various thermodynamic process. So what is the relationship which has been formed using first law of thermodynamics? So that is the question which has been asked. So we know that the first law of thermodynamics, when it is applied for any process, when first law of thermodynamics is being applied, we end up with this relation. Okay, change in heat transfer will be equal to change in internal energy plus change in work done. Right. So where this internal energy is again becoming a property, right? So I can say that the question was first law of thermodynamics furnishes the relationship between heat, work, and also the property. Internal energy is a property. It's not about the all property. So it is about the property. Okay, so I can say that option B would be the correct one. Heat, work, and properties of the system. It is not the various properties of the system. Okay. So we'll move on to the next question. So work done in free expansion process is. So this is also a famous question which has been asked in so many times in many competitive exams. This has been asked in the subsequent year of 2010. Option A positive, option B negative, option C 0, option D maximum. So see, it is said that it is free expansion. Okay. So free expansion in the sense it is not doing any work. There is no resistance involved. See, if the work has to happen, there should be some kind of resistance which should happen. So since it is freely expanding, there is nothing to stop it. So I can say that work done in free expansion is equal to 0. Since there is no resistance involved in it. Okay. So I can say that option C would be the correct answer. Then this is the next question which has been asked in the year 2010. And open system is the one in which four options have been given. Option A, mass does not cross the boundaries of the system through energy, though energy may do so. Option B, neither mass nor energy crosses the boundaries of the system. Option C, both energy and mass crosses the boundaries of the system. Option D, mass crosses the boundary but not the energy. Okay. See, the thing is, if you go for a closed system is the one where mass remains constant. Both heat interaction and work interaction can take place. Either heat can flow into the system or it can flow out of the system. Similarly, work can flow into the system or it can flow out of the system. So this is called work done by the system and this is called work done on the system. So this is related to closed system, but the question is related to open system. So open system is a one where we have, in addition to heat interaction and work interaction, as we have seen in closed system, mass interaction will also be there. There will be some mass in and there will be some mass out. So many such open devices, for example, you have compressors. So air compressors, you know, air with some mass flow rate enters and then goes out. Similarly, you have turbines, either steam turbine or hydraulic turbine. You have certain mass of steam entering in and certain mass of steam leaving out. In addition to heat interaction and work interaction, mass interaction also take place. So the options which has been given as mass does not cross the boundaries of the system, though energy may do so, is wrong. Neither mass nor energy crosses the boundaries of the system is also wrong. Both energy and mass crosses the boundaries of the system is the correct answer. So option C is the correct one. Okay. So we'll continue in the next video. So watch up to this and you can actually follow our channel for the series for the entire set of staff selection JE. Thank you.